Welcome back everyone for our third section Mine Planning Campaign webinars. My name is João Pedro. I'm a mine engineer here in Data Mine, South Africa, and I'm here with Hajar, also a mine engineer. We're gonna teach you how to generate pushbacks in NPVScheduler. Okay, so if you have any question during the webinar, please write it down and I'm gonna answer some of them later after the presentation. Okay, first let's have a quick review. In our first webinar, Hajar taught you how to generate ultimate pit using NPVScheduler. So set the block model, apply the economic parameters, and choose the best LG phase for ultimate pit. Okay, and last week Terence taught you how our automatic pit design works in Studio P. Okay, we design a pit, we add road and switchback, and we create surface. In this webinar, as I said, I'm gonna teach you how to generate pushbacks. So first we need to import the design from Studio P, that one that Terence did. Recalculate the LG phases, set the pushback parameters, and then we're gonna export the model to Studio P, similar to these pictures. Okay, we need some information. So Hajar set our production as 1.2 million tons of ore per year. We calculate the reserves on NPV. I'm gonna show you of 14.6 million tons of ore. So by the calculation, we have 12 years of life of mine, and we're gonna generate 4 pushbacks. The first two is 3 million tons of ore, and the last two 4 million tons of ore. Okay, so as I said, the first thing is to export this pit without merging with the topography from Studio P to NPV. We can do this here in optimization window. There's this data mine surface. We can select our triangle file, and then the software gonna ask you to select our point file. Then gonna show us the fields inside of this file. We are not gonna use any of them, so we can just click in none, then click OK, and here we give a name. The name that I gave was ultimate pit. Okay, so now let's see some reserves. Go to report ribbon, other pits, can select ultimate pit and press OK. The software calculates us the reserve by bench. Okay, this is the number 14.6 that I gave you in the presentation. So these numbers won't match with Studio P, and I'm gonna show you why later. Okay, here we can also go to visualize other surface, ultimate pit, and it will show us our pit. Okay, so here our resolution is 10 by 10 by 10 because the size of the blocks. NPVS only works with blocks, so you can zoom in and you guys can see. Let me go back a little bit here. The pushback. See, so the resolution is good. We can see where the things are, like where the ramps are. Okay, so let's go back to optimization. Here in ultimate pit is where I'm gonna set this information, but before that, this project is the same that Hajar used. So I just need to add a new scenario, okay, called webinar 03, okay, and then copy the information from Hajar to me, to the new scenario. Click twice to activate, and then ultimate settings, you can see that I'm having everything that Hajar said. Okay, so the first tab here, I'm not gonna change anything, but ultimate bits, instead of maximize cash flow, I'm gonna use pit shell, select from the list below. So the list, there's a lot of surface, mine is this ultimate pit, okay. We need to take care about this checkbox. I'm gonna show you later on this webinar what it does, okay. But from the moment you can press OK and rerun the ultimate pit. Okay, forgot. Sequence is also important, okay. Using tell the software to generate a lot of LG phases, because to generate pushbacks, NPVS will look after these LG phases. So as many phases you produce, more accurate will be the pushbacks. Okay, so can close and run. I'm not going to. I already did this, because it takes a time. So I have this. Can go to reports, LG phases. Okay, I have incremental and cumulative. I can change it here in tools, report options, final pit, and here I can select only incremental or only cumulative, depends on you. So what I want to show you guys is here, our last phase jumps from 88 million tons to 106 million tons. Okay, the NPV couldn't find a better phase here, so it stops and then jumps because we force them to match with our pit. Okay, we can have a better visualization here in visualize LG phases. Okay, all right, so here let's change the legend, and oops, okay, no worries. So here you can go phase by phase until it ends, but we want to see the last two phases. So here is what NPVS generates, and here you see there's a big jump. We can see better on Studio OP. So we need to go to data, export model. So we're gonna export the model like it is. Let's wait. So here, data mine block model, just press OK and give it a name. So please take care with spaces. Studio OP doesn't like spaces in the name, so use always underscore. Okay, I already did that, so let's go back to Studio OP and this one. So I am sequenced by ultimate pit by phases, and my legend is also by phases. I can click in sequence control and I can display to you guys how it works. So come here. Okay, let me not display here. So here is how our phases grows. Okay, until a point. So this point is 100 because we generate 100 phases, and after that it didn't generate until the 100 phases. You can see here as well. So our last pitch is the phase 1000, and the last phase that NPVS generates is 100. So here's the same situation. Okay, we can so here I can talk about the reserves also. So as you can see, some blocks it's outside the pit. So that's why when you evaluate by NPV and evaluate here in Studio P, it gives you difference. So NPV gonna consider only the center of the block. If the center of the block is inside of the phase, it consider all the block. If the center of the block is outside the surface, it will remove all the block. Okay, and Studio P doesn't do this, right? The evaluation from Studio P is perfect. If there is only 10% of the block inside of the pit, Studio P consider only this 10% inside. Okay, that's why you have difference. So let's continue. We can make a section here, put our block model and our surface as intersection, align to view. Let me just highlight this a little more on it. Yes. So here you can see that it didn't follow the walls. Okay. So one way of solve this is to change the slope region angle. Okay. Here I can display my block model so you guys can see which region we are dealing with. So this side is our weathered rock and this side is our ore. Of course, can be more detailed. There's some soil here, there's some other rock here. So, but it's not the focus of this webinar. So let's just calculate which is the overall slope angle so we can set this again. So let's go home, carry lines here, going to here, and you give me like 40 for weathered rock, and again line until somewhere here we have 30 degrees for ore. So let's go back to NPV. Here we can go to Ultimate Pit again. In slopes, change the weathered rock from 45 to, I note here, to 40. So just click calculate, 40, select, and OK. I'm gonna change, and the same for ore, and rerun the Ultimate Pit. Okay, I already did that as well. So here, the new scenario, if you go to slopes, weathered 40, and ore 55. Okay, we can export this new model again, the same way, data export model. And let me show you angle. So here you can see the difference, okay? Mostly in this wall. Now everything's blue. So there are some more adjustments to do, but as I said before, it's not the focus of this webinar, okay? But this block model is much better. We can reevaluate this again. We can evaluate to show you here in LG phases. Comes now 97, the last phase. Okay, so one more thing. Remember this checkbox here. If you check this, NPV won't generate the last one. It will stop here. So we're gonna lose what is our objective here. Okay, so that's why we need this to be unchecked. Okay. So now let's go to pushbacks. Here we have three options. So we're gonna use ultimate pit because we already have our ultimate pit, but I can set our phases as well. If we didn't design our pit, that's the option we be better to use. Okay. Here is very important for you guys to know. We have two options, mostly these two options. Control mining with bench, okay. The final pit may be smoother, or keep the final pit unchanged. I'm gonna use the second option, all right, because we already designed, we know the face, how our final pit looks like, so we are not gonna change this, right? Here's the mine width is this distance between pushbacks. So I like to use 40, but it's up to you what you like, okay? But how is your mind? And now here in size control, here we tell the software where to stop and when not to do it. All right, we constrain our pushbacks here. So we can edit control variables. We can add more variables. I add this total R, so I just type here like total R, and then click 1. So everything that's R be considered. Okay. I create also the total tones. So total tones is everything. I can constrain by it as well. So as it is, how the software consider. So the first pushback must have the total or 3 millions, okay? And there's no bench limit. So it's 1,000. Here I can see how many benches I have. I have 31. In this case, there's no limit in benches. And adjustments, here I can select a string. When I design, I'm gonna show you later how to do it. But in this scenario, software will consider for all the pushbacks, since the first one to the last one, to use 3 million, but it's not what we want. Okay, we want in the third pushback, our total R must be for 4 millions. Okay, and no bench limits and none as well. So here the first 1 and 2 pushback, we're gonna achieve, try to achieve 3 million, and the third one and the fourth one 4 million. Okay, one thing here is nice to see is the maximum pushback number. Okay, to set how many pushbacks you want. Let's click OK and run. Alright, so the process finished. It generated 3 pushbacks, and let's look about our R here. So it's not exactly what we want, but at least the first one, the first two, it's good. Let's have a look on it. So pushbacks. Always change this to be better. So the first one looks good. The second one looks nice as well. And the last one is everything. So let me just, okay. So we just need to change some things. All right, so let's recalculate our pushback, but now increasing this value. Okay. Okay. So here we don't need to increase the value. I made a mistake. See, instead of total tons should be total hours. So that's why it didn't find a better solution. So now let's run again. Okay. So now that is almost finishing, we can already have a look to the preview. Generate 5 pushbacks. So the first, we can have a look to see what's happening, but the first two continues good, and we don't want to generate like the 51. So to avoid that, we can reduce this 4 to 3. Okay, and I'm going to reduce a number of pushbacks. All right, but let's take a look first on our pushbacks. Okay, the first one, second one, the third one, and the last one. No, there is one more. Yes, okay. So from the second one to the third one happens this. Is not very optimal. Okay, so what we can do is constrain the way they are growing for what we want, use strings. So first let's define a horizontal section. Okay, and I'm going to show you how to constrain by strings. Clicking here in this one, just digitize pushbacks adjustment is different from the other colors. Okay, so we need to be this one. And here there's a different way of designing strings. We can do something like that. Okay, I don't know if you can if you guys can see very well here now, but there is some strings, and now I just click here in apply. I can give it a name. I like to know pushback 3, and I must not repeat the name, so pushback 3 the third try. And here there is some options how restring, how to constrain, but mostly the most used is this pushback include. So it won't let the software, the pushback, go further than my string. But if he finds everything less than this, it's possible. Or you can use force limits. So no, I want my pushback be exactly like this. All right. So I like to use this one. So depends on you. Here I can set the limit by bench, but let's have it the most as possible, because then I can limit in the bench constraint there. Okay, I already designed. Let me just display for you a string. So add here lines, can change the color and the width. I put 5 and apply, and you guys can see here the order. Okay, it's good. So this is the string that I designed. Okay, using the force limit. Okay, another thing that we can do is to know where we should constrain by bench. Okay, so we can analyze using our LG phases, not in visualize but in report. Our LG phases, we can remove only the bench, only one bench from it, only one phase from it, and then analyze properly bench by bench. This, in this case, let's analyze my third pushback. Okay, here in R must have something around 10 million tons, so I'm gonna pick the 17th phase. All right, so to extract only this phase, I need to go to Tools, Combine Files. Here I select my, to know this, here, Pushback 31. So combine Pushback 31. I just want, oh no, this is Pushback, yes. So it's optimize bit 14, yes. Combine, optimize bit 14. I just want 1, and this number is 17. Okay, I can call it bit 17. Right? I already did this here. Okay, so I'm not gonna do this again. So I can see what's happening in pit 17, in other pits, pit 17, and here analyze incremental, okay, bench by bench, how many tons of rock there is in each bench. Okay, and make some quick calculation to know the area, more or less. So just picking this number, dividing by the density, the average density, and then divide again by the bench height. So I have the meter square approximately. Okay, so in this case I choose this one. I already made the calculation, and this gives me a good area. So I write it down this elevation so I can use later. Okay, and I repeat this process for the other 2 pushbacks as well. And then I have my final pushbacks. So here my source console is 3. Okay, using pit unchanged, and I set like this. Okay, I using my string to limit the area, using my bench limit to limit my pushbacks, and then I just click OK. So one thing, we pick this bench, right? 1145 or 1147. So we can look for 1147. There is none, but there is this 1142. Then I use here. All right. So I just press OK and run. So I already run this. So just here, pushbacks. So this is my results, my R. So I'm very happy. I don't know if you guys noticed there's two more fields here. I can add them here in tools, report option. Here in pushbacks, I can set which one I want to include, so incremental, clicking more options, and here add formula first. So for instance, strip ratio is rock minus R divided by R. Okay, this already exists, so I already have this. And just click this and add field and put the name for it. And we need just to, and then I've pressed OK. We just need to rerun the report. Just click again, pushbacks, and it will appear this calculation. I set the strip ratio and profits. Okay, we can see, let's see our pushbacks. Okay, let me display my string so I can prove that it's respecting. Changing 5. Okay, so 1, oops, 2, 3. So horizontal, so you see, is respecting. And my last one, like that. So now I'm very happy with my results. I can go to tools, data, export model, do the same procedure, and let's display it in my studio. Let me put as flat and display my pushbacks. Okay, just for you guys to know, I sequence as my pushback sequence, but I am legend as my pushbacks bits. Alright, can close this. Sequence control, and then let's go back. So you see, now I mine bench by bench to NPV, mine bench by bench each pushback before I started the other one. Okay, I know this import and export model is kind of painful, but no worries, we are already developing the Studio NPVS that will come soon, and then it will have this 3D environment and will make our life much easier, right? So the next step now is design the pushbacks and then re-import it in our NPV for then make the schedule. Okay, so guys, that's it for today. Thank you very much for your attention. This is my email, this is Hajar's email. You can email us asking questions. Okay, thank you very much.